Okay, so it looks like I'm gonna have to go to my office to get the new link and send it to everyone. So we'll be right back. Is it working? Did you check your email? Okay, we had some technical difficulties. The original link wasn't working this morning. So we'll try the new link. Looks like some people are logging in. Today we'll be in section 9.3, chapter 9, section 3, on solving quadratic equations using the quadratic formula. Okay, any quadratic equation can be solved by completing the square. That's what I said yesterday. And consequently, a formula can be derived by completing the square to solve any quadratic equation. That formula is called the quadratic formula, and we will derive it below. So if we begin with the equation ax squared plus bx plus c equals 0, where a, b, and c just represent real numbers, the variable is x, and also a cannot be 0. We can solve this by completing the square, and the result is called the quadratic formula. So what we do is we begin by subtracting c from both sides. And when we subtract c, we get ax squared plus bx equals negative c. Then we divide every term on both sides by a. Ax squared divided by a is x squared. B times x divided by a, we'll write that as b over a times x. And then on the right-hand side, negative c divided by a. The next step is the completing the square step. Since the coefficient of x squared is 1, what we do is we take 1/2 of b over a. So 1/2 times b over a is b over 2a. Then we square that quantity. We square b over 2a. And we can write that as b to the second over 4a to the second. And this is the number that we're going to add to both sides of this equation up here. So we write x squared plus b over ax plus b squared over 4a squared. And we also add that quantity to negative c over a. But I'm going to put that term first, b squared over 4a squared, and then minus c over a. The left-hand side is a perfect square trinomial. And then on the right-hand side, we want to write a single rational expression with a common denominator. So we can do a couple of things at once in the next step. Since this is a perfect square trinomial, x squared plus b over ax plus b squared over 4a squared, that is equal to some binomial squared. We'll come back and figure out what that binomial is in a minute. On the right-hand side, the least common multiple of the denominators is 4a to the second. So we'll leave this term, b to the second over 4a to the second, the way it is, and we'll multiply negative c over a by 1 in the form 4a over 4a, so that we'll get a common denominator of 4a to the second. Hey, to determine what binomial it is that we have to square to get the perfect square trinomial, since the perfect square trinomial has x squared in it, the binomial has to have x. And then the number that follows the x is the same number we got when we took 1/2 times b over a, which is b over 2a. So we're going to add b over 2a. We'll simplify the right-hand side a little bit more. So the left-hand side stays the way it is for now, x plus b over 2a quantity squared. And on the right-hand side, with a common denominator of 4a to the second, we can write the numerator as b squared minus 4ac. B to the second minus 4 times ac. Okay, now we can apply the square root property, because we have a binomial squared equals a number, b to the second minus 4ac over 4a squared. So when we apply the square root property, the left-hand side is x plus b over 2a, and the right-hand side is positive and negative square root of b to the second minus 4ac divided by 4a to the second. Inside the square root, the denominator is a perfect square, so we can simplify this square root. So we'll simplify the square root first before we do the last step. So we have, for now, we have x plus b over 2a equals positive and negative square root of b to the second minus 4ac divided by the square root of 4a to the second, but the square root of 4a to the second is 2a. Okay, then the next step is the final step. We subtract b over 2a from both sides, and we will write it as x equals negative b over 2a plus and minus the square root of b to the second minus 4ac over 2a. And you can remember the quadratic formula in this form if you want, but since the denominators are the same, an alternative way to write the quadratic formula is x equals negative b plus and minus the square root of b to the second minus 4ac, all divided by 2a. Okay, one way or the other, make sure that you know this quadratic formula. If you forget just one thing in that formula, then that will lead to an incorrect answer or solution. So it would be a good thing if you could, by yourself, derive it the way that it's derived here. That being able to derive it will reinforce memorizing what that quadratic formula is. Okay, so as has been mentioned a few times already, every quadratic equation can be solved by completing the square. So if you don't want to use the quadratic formula to solve a quadratic equation, you don't have to use the quadratic formula. You can always just solve by completing the square. Okay, the number b to the second minus 4ac that's inside the square root in the quadratic formula is called the discriminant. And the discriminant indicates how to classify the solutions to the quadratic equation ax squared plus bx plus c equals 0. Okay, so if we think about these three statements that follow, it should make sense. If b to the second minus 4ac is greater than 0, then that number that's inside the square root is positive, and the square root of a positive number is a real number. So if b to the second minus 4ac is greater than 0, the equation ax squared plus bx plus c equals 0 has two different or two distinct real solutions. Because in one case, negative b plus a real number divided by 2a is one solution. The other solution is negative b minus that real number divided by 2a for the second real valued solution. Okay, but it's possible for the discriminant b to the second minus 4ac to be negative, which means that it's less than 0. And if the discriminant is negative, we know that the square root of a negative number is a non-real complex number. And so if the discriminant is negative, the quadratic equation ax squared plus bx plus c equals 0 has two different or two distinct non-real solutions. And then the third possibility, if the discriminant is exactly 0, then the quadratic equation ax squared plus bx plus c equals 0 has one repeated real solution. So if the discriminant is 0, what kind of trinomial are we dealing with? So you know the answer. If there's one repeated real solution, that means in the factorization of the trinomial, there are two identical binomial factors. So if you have two binomial factors that are the same, exactly the same, and you multiply them, what do you get?
Is it a perfect square trinomial?
You get a perfect square trinomial. So the quadratic expression by itself could be a perfect square trinomial or a constant multiple of a perfect square trinomial. One or the other, when the discriminant is 0. Okay, we'll solve a bunch of equations using the quadratic formula. So here's the quadratic formula up here. So you need to practice using the quadratic formula, even if you always choose to solve a quadratic equation by completing the square method. So on this first one, x to the second minus 7x minus 2 equals 0. A is 1, B is -7, and C is -2. So we write x equals the negative of -7 plus and minus the square root of the number -7 squared minus 4 times 1 times -2. And all divided by 2 times 1. So if you're still struggling with subtraction and negative terms, you'll need to hone your skills because you're going to encounter many opportunities to make a mistake. So let's start simplifying. The negative of -7 is +7, and then plus and minus the square root of a number. This first number inside the square root, the number -7 squared, is +49. And we're subtracting 4 times 1 times -2. So we're subtracting -8. And then in the denominator, 2 times 1 is 2. And we have one step left. X equals 7 plus and minus the square root of a number, all divided by 2. So 49 minus -8 is the same as 49 plus 8. I guess we can go ahead and write the additional step 49 minus negative 8 is 49 plus 8. And then our two solutions are 7 plus and minus the square root of 57 divided by 2. The square root of 57 cannot be simplified any further, so those are the two solutions. Okay, in the next example, 3x squared minus 5x plus 1 equals 0. So for this one, a equals 3, b equals negative 5, and c equals 1. So x equals negative b, so that's the negative of negative 5, plus and minus the square root of the number negative 5 squared minus 4 times 3 times 1, all divided by 2 times 3. Then in the next step, the negative of negative 5 is 5, plus and minus the square root of a number. Inside the square root, we have the number negative 5 squared, which is 25, and we're subtracting 4 times 3 times 1, we're subtracting 12. And then we divide it all by 2 times 3, which is 6. And then the last step, x equals 5 plus and minus the square root of 13, all divided by 6. So you have to make sure that you divide 5 by 6 as well as the plus and minus square root of 13. Divide that by 6. Okay, the next example, negative 2x squared plus x plus 4 equals 0. So in this one, a is negative 2, b is positive 1, that's the coefficient of x, and c is positive 4. So our solutions, x equals negative b, so negative 1 plus and minus the square root of 1 squared minus 4 times negative 2 times 4, all divided by 2 times negative 2. Okay, so x equals negative 1 plus and minus the square root of a number. So 1 squared is 1, and we're subtracting 4 times negative 2 times 8. So we're subtracting negative 32. And we're dividing by negative 4. Okay, so down here, x equals negative 1 plus and minus the square root of 1 minus negative 32, that's just 1 plus 32, so the square root of 33, and then divided by negative 4. When you get to the Newton software, I'm pretty sure that you're going to not be able to type in a negative denominator. So you will need to be able to simplify this. And it's not too bad if you think of multiplying by 1 in the form negative 1 over negative 1. So multiply the entire numerator by -1 and the denominator, multiply that by -1. You're going to get -1 times -1 is +1. And then the plus and minus will be equivalent to the minus plus, which is equivalent to plus minus. So you can just write plus and minus the square root of 33 again. And then -1 times -4 is 4. Okay, but I wanted to save this space over here to show you an alternative, which I've alluded to already, I think yesterday. We're starting out with -2x squared plus x plus 4 equals 0. So in my opinion, it makes the arithmetic a little bit easier if you start out, since the coefficient of x squared is -2, if we start out by multiplying every term on both sides by -1, the solutions to the equation will be the same, but without a negative leading coefficient, the arithmetic will be a little bit easier. Okay, so multiply every term on both sides of the equation by -1. So -1 times the quantity -2x squared plus x plus 4 is 2x squared minus x minus 4. And on the right-hand side, -1 times 0 is still 0. So for this quadratic equation, we're using a equals +2, b equals -1, and c equals -4. And then we use the quadratic formula. X equals the negative of b, so that's the negative of -1, plus and minus the square root of b squared minus 4ac. So b squared is -1 squared minus 4 times 2 times -4, all divided by 2 times 2. So in the numerator, the negative of -1 is +1, and then plus and minus the square root of a number. So inside the square root, the number -1 squared is 1, and we're subtracting 4 times 2 times -4, so we're subtracting -32 again. And the denominator is 4. And then we simplify what's inside the square root. Inside the square root, 1 minus -32 is the same as 1 plus 32, or +33, all divided by 4. So whichever way you prefer is fine, but in all cases, you'll always have to be careful with the arithmetic. Okay, the next problem . The solutions to ax squared plus bx plus c equals 0. Here's the quadratic formula. X equals -b plus and minus the square root of b squared minus 4ac, all divided by 2a. Okay, solve this quadratic equation using the quadratic formula. In this one, a is 4, b is -3, and c is +2. So x equals the negative of -3 plus and minus the square root of the number -3 squared minus 4 times 4 times 2. all divided by 2 times 4. Okay, now we do some arithmetic. The negative of -3 is +3, and then plus and minus the square root of a number. So inside the square root, the number -3 squared is +9. And we're subtracting 4 times 4 times 2. We're subtracting 32. And we're dividing by 8. 2 times 4 is 8. And then x equals 3 plus and minus the square root of -23, all divided by 8. Well, we now know how to handle square roots of negative numbers. We're going to replace the square root of -23 with I times the square root of 23. So write the solutions as x equals 3 plus and minus I times the square root of 23, all divided by 8. So as before, it's okay if you put the factor I to the right of the square root of 23. You just have to make sure that you don't put I inside the square root. So these two solutions are non-real complex solutions. Okay, the next example, -6x squared plus 5x plus 3 equals 0. So we can proceed as written using a equals -6, b equals +5, and c equals +3, and use the quadratic formula. Or, if you prefer, you can, since we're starting out with -6 as a coefficient of x squared, if you prefer, we can multiply every term on both sides by -1 and solve this equation, +6x squared minus 5x minus 3 equals 0. The solutions to the two equations are exactly the same. It just comes down to your preference. So let's go ahead and use it with a equals -6, b equals 5, and c equals 3. So x equals -5 plus and minus the square root of 5 squared minus 4 times -6 times 3, all divided by 2 times -6. So -5 plus and minus the square root of some number, all divided by -12. So inside the square root, 5 squared is 25. And we're subtracting 4 times -6 times 3. We're subtracting -72. So then we get x equals -5 plus and minus the square root of 25 plus 72, which is 97, all divided by -12. Okay, so to fix this, -5 plus and minus the square root of 97 over -12. Well, on paper, this is a fine answer, but in the Newton software, you won't be allowed to type it in this way. So if we multiply both the numerator and denominator by -1, we'll get x equals +5 plus and minus the square root of 97 divided by +12. Okay, another example. So there's no end to how much you can practice using the quadratic formula. So 5x squared minus 5x minus 4 equals 0. So a equals 5, b equals negative 5, c equals negative 4. Okay, so x equals negative b, so that's the negative of negative 5, plus and minus the square root of the number negative 5 squared minus 4 times 5 times negative 4, all divided by 2 times 5. Okay, then we do the arithmetic. The negative of negative 5 is 5, plus and minus the square root of the number negative 5 squared is 25, and we're subtracting 4 times 5 times negative 4. So we're subtracting negative 80 and dividing everything by 10. So a little bit more. X equals 5 plus and minus the square root of 25 minus negative 100 is 25 minus negative 80 is 25 plus 80, which is 105, all divided by 10. The square root of 105 cannot be simplified. Whenever we can simplify the square root, we have to do that, but so far we haven't had to. Okay, on the next sheet, the directions here, use the discriminant b to the second minus 4ac to classify the solutions. So by classify the solutions, I mean what was pointed out a few minutes ago. If the discriminant is positive, there are two different or two distinct real solutions. If the discriminant is negative, there are two different or two distinct non-real solutions. And then the third case, if the discriminant is 0, there are two repeated real solutions. Okay, so in this one, the value of b is negative 7, a is 6, c is 9. And so the discriminant, b to the second minus 4ac, is the number negative 7 squared minus 4 times 6 times 9. Negative 7 squared is 49. And then we're subtracting 216. 4 times 6 times 9 is 216. And then 49 minus 216 is negative 167, I think, isn't it? So let's see. 50. I think that's right. Is that what you get? Okay, so negative 167 is the discriminant. So what does that mean? Since the discriminant is negative, there are two different non-real solutions, or two distinct non-real solutions. Okay, then it says find the solutions. Well, we already found the discriminant. So y equals the negative of -7 plus and minus the square root of the discriminant, which is the square root of -167, divided by 2 times a, or 2 times 6. So the negative of -7 is 7, and then we simplify the square root of -167 by writing I times the square root of 167, and then all divided by 12. Okay, the next one, n to the second minus 8n plus 5. So find the discriminant. So on this one, b is -8, a is 1, c is 5. So b to the second minus 4ac. The number -8 squared minus 4 times 1 times 5 is 64 minus 20, or positive 44. Okay, since the discriminant is positive, that means there are two different real solutions. Okay, now we find the solutions using the quadratic formula. Make sure you use the correct variable. The variable in this equation is n. So n equals -b, or the negative of -8, plus and minus the square root of the discriminant, or the square root of 44 in this case, divided by 2 times a, or 2 times 1. Finally, we have a square root that can be simplified. So the negative of -8 is 8, plus and minus, and then the square root of 44 is the square root of 4 times the square root of 11, and the square root of 4 is 2. So we have 8 plus and minus 2 times the square root of 11, all divided by 2. And we can simplify further. So beware of how the correct way to simplify this. Every term in the numerator has a common factor of 2. So if you want to factor 2 out of everything first, so 2 times the quantity 4 plus and minus the square root of 11 divided by 2. And the factor 2 from the numerator divided by the factor 2 from the denominator equals 1. So our two solutions are just 4 plus and minus the square root of 11. Okay, the next one, 49a to the second minus 84a plus 36 equals 0. Okay, so on this one, b is -84. A is 49. C is 36. Okay, so b to the second minus 4ac is the number negative 84 squared minus 4 times 49 times 36. Well, with your high-powered calculator, you'll find that this is what number?
$7,056.
What?
7,056.
The whole number?
Oh, no. The whole number that all equals 0.
Yeah, so negative 84 squared minus 4 times 49 times 36 equals 0. So the discriminant is 0. What does that mean? It means one repeated real solution. One repeated real valued solution. So this is the number that's inside the square root. The square root of 0 is 0, which is a real number. Okay, so to find the solutions, so a equals the negative of negative 84 plus and minus the square root of 0 divided by 2 times a, or 2 times 49. So we get the negative of negative 84 is 84 divided by 2 times 49 is 98. And then this can be written in lower terms. Let's see. 14 is a common factor. 14 times 6 is 84. And 14 times 7 is 98. 14 divided by 14 is 1. And so the repeated solution is 6/7. Okay, but I'll remind you of another method. So in this quadratic equation, the greatest common factor of all of the terms on the left-hand side is 1. Greatest common factor is 1. The term on the left is a perfect square. 49a squared is a perfect square. The term on the right is also a perfect square. So in general, whenever you see a trinomial where the term on the left and the term on the right are perfect squares, you should wonder if it's a perfect square trinomial. And it is. Remember what we said earlier, when the discriminant is 0, there is either a perfect square trinomial or a constant multiple of a perfect square trinomial. And in this case, we just have a perfect square trinomial. And we know how to factor those. So this will be the last thing for today. The two factors of that are 7a minus 6 times 7a minus 6. So when you solve, you get one repeated solution of 6/7. Okay, that's all for today. Tomorrow we'll review the material from 9.2 and 9.3. We'll continue the worksheet that I sent you that we didn't complete today.